Okay, so we're going to look at the GCF and factoring by grouping, which is section 6.1 in Unit 10. This was done January 7th. Okay, so this will be for your Unit 10 homework numbers 1 through 10. Starting with the basics, looking at the greatest common factor, okay, which is just the greatest or biggest factor that terms have in common. Okay, so the greatest or biggest factor that terms have in common. That's what we're looking at. If I can get the camera to stop twisting on us. Okay, so when we look at these, within each term, okay, that's super important. Remember, terms are separated by those plus or minus signs. So here I'm going to have two different terms. So within both of those terms, I'm looking for what do they have in common. Well, here, I could divide each of them by 6 evenly. By doing so, if I factor that GCF out, that's the greatest common factor, so the 6 goes out front, and essentially what's happening is we're dividing each one of these by 6. So we're going to take the 6 out front. What I remain is 2 plus 3, because 18 divided by 6 is 3. It's super important to note that when I go backwards with this, if I redistributed this, I would end up back at my original problem. So here, if I multiplied this 6 back in, I would get 6t plus 18, which is what I started with. So that tells me that I did my math correctly. Okay, so the same thing's going to happen with b. There's a lot more complicated, there's a lot more stuff going on, but we're still looking for the same thing. Starting with the numbers, okay, between 25, 15, and 5, I'm looking for what is my greatest common factor. Here it's going to be 5. 5 goes into each one of those numbers evenly. Okay, but I can't just do, I can't just do the numbers, I have to look at the x's and the z's as well. I have an x in all three terms, that means I can definitely take an x out. And to determine x to what power, you just find which one has the smallest exponent. So I've got a 4, a 3, and a 2. So x squared is the largest that I can take out. Okay, I can't take out an x to the 4th because I don't have 4 of them here. So I can only take out whatever the smallest term is. I also have a z in all three terms. So I can take a z out, and these are all z to the first power, so this is going to be z to the first power. Now we have to parenthesis, and now we have to write down what we have left out of each term. So if I took this first term and I divided out the 5x squared z, what would be left? Well, 25 divided by 5 is 5. If I had x to the 4th and I divide out x squared, well, that's just a subtraction. So we've got x squared, and I had 4, I took out 2, I'm left with 2. I had 1z, I took that 1z out, so I'm left with no more z's left inside the parentheses. So that's the end of the first term. That's just this piece. Now we've got to move on to the next piece. So plus 15 divided by 5 is 3. I had 3 x's. I took out 2, so now I have 1 left. I had 1z. I took out 1z, so I have no more z's left. Done with that one. Moving on to the last one now. 5 divided by 5 is 1. X squared divided by x squared is also 1. Z divided by z is also 1. So when all is said and done, I'm left with a 1. Now this is a very important principle of this unit, is if I take out the entire thing, notice this was 5x squared z, and what I'm factoring out is 5x squared z. If those two things match, I must leave a 1 in its place. Okay, this can't just disappear. 5x squared z divided by 5x squared z is 1. So you have to have that 1 in the place. The reason being is that when I distribute here again, okay, when I multiply this into each one of these terms, I would get 25x to the 4th z plus 15x cubed z plus 5x squared z. Without that 1 there, we wouldn't have the last term. So you have to have the 1 in its place. Now looking at c, it looks a little bit different, but it's the exact same principle. So here, not only can I take out individual numbers or individual variables, I can also take out entire terms. So here I have this is a factor and this is a factor. Notice they both match exactly. Signs are the same, numbers are the same, everything. X plus 3 and x plus 3. So just like here I can factor out a 6, here I can factor out an x plus 3 because I have an x plus 3 in both terms. So we're going to take that x plus 3 out front. Here, if I divide by x plus 3, okay, in just this very first term here, when I divide by x plus 3, I am left with 5. Okay, do you see how the x plus 3, it goes away? And then here, if I take out the x plus 3, I'm left with just a y. So that would be my final answer, x plus 3 times 5 plus y. Okay, so the same thing here. On this very last one, I've got an a plus b and an a plus b. Both of those two things match, which means I can factor that out. So the a plus b is going to factor out to the front. Okay, the a plus b, we are going to factor that out to the front, and then we're dividing each term, this term and this term, by the a plus b. So this first term, once I take the a plus b out, I'm left with the 3m squared n. Okay, and then on the second one, I have minus this right here. Now if I do a plus b divided by a plus b, I'm left with a 1, and since this was minus, this is still minus. Okay, negative a plus b divided by a plus b gives me a negative 1. Don't forget to leave the 1 in that place. Okay, so that's the basics on pulling out a GCF, or greatest common factor. Okay, so just to kind of show you your turns here, same sort of concept. First, start by looking at the number. I've got a 12 in both of those, so I'm going to pull a 12 out. I also have an a that shows up in both terms. Okay, I also have a b that shows up in both terms. Okay, the a I only do to the first because that's the smallest one there, and as well as b. b to the first power because that's my smallest exponent. That's how I know which exponent to use. 24 divided by 12 is 2. My a's there cancel. I had 2 b's. I'm taking out 1, so I'm left with 1 b. Okay, same thing here. 12 divided by 12 would give me a 1. This was negative, so we get a negative 1. A squared divided by a, we have 1a left. My b's here will cancel. Okay, that negative 1, that 1 that's sitting out here in front, of course, it's not necessary. Okay, because I do have an a behind it, so you don't have to write the 1a. I'm just doing it so you can kind of see what's happening. If you need to actually physically write out the dividing out 12ab on both of them, if that makes that easier for you, you can always do that. Okay, the 24 divided by 12 is 2. The a's here would cancel. My b's would reduce, so I have a b left on top. Same thing here, 12 divided by 12 is 1. My a squared over a would give me an a, and b over b's would cancel. So if you need to actually physically divide it out, just like we physically divided it out here, you're welcome to do that. There's nothing wrong with that. Okay, and this last one here on your turn, same sort of thing's going to happen. So that x plus 2, we factored that out. Okay, anytime you see those parentheses show up in these kind of problems, that should kind of ring a bell and draw your attention that that's probably what's factoring out, but they do have to be identical. That's super important. That's going to come up when we do our factor by grouping. So the x plus 2, it factors out front, and then what I'm left with is the 4x and the minus 3. So 4x minus 3, and that's what's going to show up in that second parentheses is what's left. So that's what we are going to consider to be pulling out a GCF, okay? So factoring out the greatest common factor. Now the next part we're going to look at is factoring by grouping. So to factor by grouping, we have a little step-by-step that you can follow. This kind of helps. If you find yourself getting stuck, go back to the step-by-step, say, okay, did I do this, did I do this? So starting with, you want to arrange your terms so that the first two terms and the last two terms have a GCF. Okay, you want the first two terms and the last two terms to have a GCF. Once you do that, you will factor the GCF from each pair of those terms. Okay, you're going to factor the GCF from each pair of those terms, and we'll look at these in a second. Okay, that last little step, if there is a common factor, okay, so if there is a common factor, then you're going to factor that out. That's going to look something like this step right here, but I'll show you that in just a minute. And step 4 says that there is no common factor in step 3. You're going to have to try to rearrange the terms differently, okay, and try again. If you still can't find a common factor, then it cannot be factored, okay? That means it cannot be factored. So let's take a look at these. So notice here that we have 4 terms. 1, 2, 3, 4. Factoring by grouping. We use factoring by grouping with 4 terms. Okay? You might want to make a little note to yourself. Use with 4 terms. Okay, because we're going to learn lots of different methods for factoring, so you definitely want to be able to identify when you should use which particular process. So we're going to use this when we have 4 terms. So I've got 4 terms listed down here. Okay, so factoring by grouping. Essentially what happens is we are going to group this. Okay, so we're going to be looking at the first 2 terms by themselves and that second 2 terms by themselves. So here, let's see if we can get a little zoom so we can see this just a bit better. Okay, so we're going to take a look at, so I've got xy plus 2x. I'm looking at just this part first. Okay, just the xy plus 2x. So within those 2 terms, okay, I'm looking at, do I have a GCF, which I do. I have an x in both of them, so I'm going to factor the x out. Okay, once I take the x out, here when I divide an x out, I'm left with a y, and here when I divide an x out, I'm left with a 2. Okay, so that's within that first set. Now I can do the same thing with that second set. So here we go. I've got a positive 3y plus 6. Now I'm going to take a look at what my GCF is. Here I've got a 3 in common with both of them. Okay, so when I divide a 3 out here, again, if you need to actually write it out, that's fine. So if I divide a 3 out here, I'm left with a y, and 6 divided by 3 is 2. Now when I get to this step, this right here is going to be step 3. That's where we're at. We already arranged them. We factored the GCF. And now we're going to take out that common factor. The common factor is if this set, what's in your parentheses, if they are the same, only if they are the same. If they're not the same, then you can't do the next step. You have to go back, rearrange your 4 terms in the beginning, and try again. But since mine are the same, I've got a y plus 2 and a y plus 2. Now I can do it just like we did up here on B, on the your terms, where I have similar factors here, and I factor that whole thing out, and I write down what's left. So I'm going to do the same thing on the one we're on. So we're going to factor out the y plus 2, and we are going to have an x plus 3 left. Okay, a y plus 2 is inside, and an x plus 3 is going to be what's left. Okay, a y plus 2 and an x plus 3. Now, that is what that looks like there. So on B, when we get to B, okay, there's 2 options here. I can go with exactly the way they're set up, which I'm going to show you first. Okay, let's just say I don't rearrange them whatsoever. I still have a GCF. Okay, if I just split these things exactly the way they're set up, in my first set here, I have a GCF of x. So I can take that x out front, and I have a 3x plus 4y that's left. Again, here I'm just dividing each one by x, so we're reducing that out. Now on the second part, I don't really have a whole lot here, but what I can do is notice I have a negative and a negative. Okay, I have a negative here and a negative here. Well, I want what's in my parentheses to both be positive. So if I take a negative 1 out, if I factor a negative 1 out, then both of these will switch signs. Because if I divide this by negative 1, I now have positive 3x. And if I divide this by negative 1, I now have positive 4y. You can double check these always by multiplying it back in. If I did, I would get negative 3x and a negative 4y. So that allows me to take a GCF out, even though there really is no common factor between 3 and 4 or x and y. I can always use 1. Okay, I can always use 1. Just a second, my screen went blank here. Okay, so I can always use 1. That is always a possibility. So by using 1, that allows me to set it up, because now if you look what we have, I've got this perfect little matching set. Okay, 3x plus 4y and 3x plus 4y. Again, they have to match perfectly. Okay, the signs can't be off or anything like that. They must be perfectly matched. So let's factor out our 3x plus 4y. And we are left with x minus 1. That goes in my second set of parentheses. Do note the format that you get in these. When I'm factoring these, I have a binomial times a binomial. Same thing here, binomial times a binomial. This is going to be a common thing that you should see when you're doing these. So if you get something else, you might want to double check your work. So the other option, I told you there was 2 options to this, which I will do in a different color. So if I wanted to rearrange, which I absolutely could, I could have rearranged these to start with. Okay, so this is one method. Let's just kind of box that out, and let's go with method 2. Okay, so method 2 is going to look exactly the same. The only difference here is that I would rearrange it. Because some of you may have noticed that there was a 3 and a 3, and then we had a 4 and a 4. So I'm just rewriting the order of these ones right here, keeping their signs with them and everything. So then when I do my factor by grouping, here I can take out a 3x, and I'm left with an x minus 1. Remember, when I divide, okay, 3x divided by 3x gives me the 1, so I have x minus 1. Same thing here, if I'm going to divide out a GCF of 4y, so positive 4y. Here I would have x minus 1 again, and here I have an x minus 1. Well, these things still match, so they're going to pull out front, x minus 1, and now I've got a 3x plus 4y as my other 2 terms. Notice that they match. Okay, look at my 2 answers. I've got 3x plus 4y times x minus 1, and x minus 1 times 3x plus 4y. Okay, the order in which these things happen isn't going to matter. Okay, multiplication, it does not matter what order it happens in. 2 times 3 is the same as 3 times 2. Same idea here. Okay, they can be written in the opposite order. You're still going to get the same answer. So that's your options there. Remember, you can always rearrange these things. If you see a pattern that makes it look like it might be a little easier for you, go ahead, rearrange them. That's fine. Okay, so C. Again, we can go about rearranging them. We could choose not to. I'm going to leave it the way it is because most people tend to not rearrange them. I don't really know why. We just tend to not. So I'm going to not rearrange them. I'm going to leave them. I'm going to take the GCFs out the way they are. So here, x cubed plus 4x. I can take an x out front. That would leave me with x squared plus 4. Okay, I took an x out of each one of them. Here, notice that it says x squared plus 4. I want my parentheses to say x squared plus 4. So what do? I have no GCF. When I have no GCF, I just used 1. Okay, I just pull the 1 out front. X squared plus 4. I just pull the 1 out front, and that's really only so that my formatting looks the same. That way, when I get to this next step, I've got my x squared plus 4. Those 2 little pieces match up perfectly, so we're going to factor them out, put it up front, and what's left? X, and then plus 1. Okay, x and then plus 1. So if you have no greatest common factor, keep in mind you can always use 1. We use positive 1 if this piece already looks the way we want it to. For instance here, x squared plus 4, that's exactly what we wanted. Okay, and I can use a negative 1 if I need both of my signs to change. So if it looks the same, only my signs are opposite, take that negative out, and that will allow our signs to change. We'll get to see one of those here in a little bit. Okay, so let's quickly go through the your turns. I think you've had enough of the explanation. Okay, factor by grouping. Split it. Okay, looking at the very first piece, just the first piece, 6x minus 42. My GCF there is just 6. Okay, so I get x minus 7. Okay, 42 divided by 6 is 7. I could multiply it back in, I would get back here. Okay, here my GCF is a positive y. Again, I use a positive here because this is x, this is positive, negative. This is already positive, negative. I don't want my signs to change, so I'm going to take a positive number out. Here I would get a positive x, negative 7. That's what would be left inside. Here I've got my x minus 7 in both, so it comes out front, and I'm left with 6 plus y. Okay, 6 plus y. So that's what that one would look like, and that's just your answer, by the way. There's not a whole lot more to it than that. Next unit you'll get to see how to solve them. From now, we're just looking at the factoring. Now, B. Okay, if you look right there at the top, and you can see it in the screen here, remember to pull out the GCFs first. Okay, pull GCFs out first. So we're going back to that very first step. Within these, we have to look and see if we have a GCF. This one's kind of obvious. I have a 4, a 4, a 2, and a 2, which means I have a 2, okay, that is common to all 4 terms. We're talking about all the way across. Okay, so before I even get started, I'm going to factor that 2, and it's going to come out front. So I'm going to divide each one of these by 2. So I'll be left with 2ax minus 2ab minus bx and plus b squared. So I divided each one of those coefficients in the front there by 2. Okay, so taking that GCF out will allow us to simplify. Yes, I did use brackets, and that's just to make sure that 2 doesn't accidentally get multiplied back in. So once I'm here, we're going to go back to factoring by grouping. I have 1, 2, 3, 4 terms. Since I have 4 terms, that means factor by grouping. Okay, so group this thing up. We're going to look at the left 2 first, and then the right 2. So starting with the left 2, I'm looking at what is my GCF between those 2 terms. Okay, that 2 that's out front, it's going to come straight down. We're going to leave it alone. And now here, I've got a 2 and an a in both. So the 2a comes out front, parentheses, I'm left with an x minus b. Okay, if I divide out the 2a, divide out the 2a, you can see here I would have just an x left and just a b left. Okay, so just the x minus the b. That's just the first part. Now let's take a look at this second part here. Okay, within these 2 terms, my GCF is just a b. Now here's what I was talking about with the negatives. Here I have positive and then negative. Here I have a negative and then a positive. I need those signs to change because I want it to end up like the parentheses, positive and then negative. So when I factor, I will factor out not just a b, but a negative b. By taking out a negative b when I divide here, okay, negative b and negative b, those will cancel. I'll be left with a positive x. B squared divided by negative b, a positive over a negative makes a negative b. Okay, so if I need my signs to change, these were opposite. I had negative, positive. I wanted positive, negative so that these 2 things match. I just take a negative out when I factor out whatever my number or letter is. Okay, so we finish off. Okay, I still haven't finished my factoring by grouping. I have a greatest common factor here, and it is the x minus b. So that x minus b is going to come out. That 2 is still out front. Okay, we can drop the brackets now because we're not going to need them anymore. We get the x minus b out front, and what I'm left with is 2a minus b. Okay, that 2, this one's the 2 from the very front. Notice it drops all the way down. Be very careful not to lose that 2 in front. That tends to happen a lot. Okay, keep that 2 out front. That's why I use my brackets That way it doesn't accidentally get multiplied in. You don't want to end up with a 4a here. That's going to change your answer. So you want to leave that number out front all the way down. Just make sure it ends up in your final answer. Make sure that ends up in your final answer. So that's the end of factoring by grouping and factoring out GCFs.